So we're skipping over 3.4, which we didn't really technically skip over it because we did 3.4 at the beginning of this unit. Remember the complex numbers, the I squared, stuff like that? That was 3.4. So now we're into 3.5, completing the square. So we're solving quadratic equations by completing the square. So a few days ago, we solved equations of the form u squared equals d, where we took the square root of each side. So we had an x squared term and some other number. We took the square root of both sides, and that was our answer. Does everyone remember that kind of? This method also works when one side of an equation is a perfect square trinomial and the other side is a constant. What I mean by perfect square trinomial is something that I can factor, and it's a binomial squared. If I factored x squared minus 16x plus 64, I'd get x minus 8 times x minus 8, which is just x minus 8 squared. So that's what we would call a perfect square trinomial. So if we factor it, it becomes a binomial squared. So let's look at an example. It's the very same trinomial I put up on the previous slide. It says solve x squared minus 16x plus 64 equals 100 using square roots. So let's just break down how we factored it earlier. Have my two sets of parentheses, my variable, my signs are minus, minus. And I was looking for two numbers that multiplied to give me 64, added to give me negative 16. What are they? Negative 8, negative 8. So that's how we got x minus 8 times x minus 8, not 1,000. Which, like we said, is just x minus 8 squared. Does everyone see that? Questions so far? How can I solve this now? If I'm solving this using square roots. How do I get rid of a squared term on something? Take the square root of both sides, right? If I take the square root of this, that squared is going to go away. So I'd just be left with x minus 8. And then what's the square root of 100? 10. Just 10? Plus or minus 10. Does everyone see that? And then how would I solve for x? Add 8 to both sides. Add 8. Add 8. So I get x equals 8 plus or minus 10.
Can you not add 8 to 10?
I'm getting there. So I get x equals 8 plus 10, which equals 18. So there's my first solution. And I get x equals 8 minus 10, which gives me negative 2. Does everyone see that? You don't get it?
Why would it just be x equals plus or minus 18?
Because we have to do
Oh, the plus
8
or minus?
plus or minus 10.
Okay.
So it's 8 plus 10, 8 minus 10. Which gives me 18 and negative 2. Any questions on that first example? Does that make sense? If your left side's a perfect square trinomial, we can factor it to become a binomial squared. Solve the equation by taking the square root of both sides. Everyone got it? So like we said in example 1, the expression x squared minus 16x plus 64 is a perfect square trinomial because it equals x minus 8 squared. Sometimes you need to add a term to an expression, x squared plus bx, to make it a perfect square trinomial. So that's the process called completing the square, which is what we're going to focus on today. We're going to add something to our x squared plus bx expression to make it a perfect square trinomial, to be able to make it a binomial squared. Sounds kind of complicated, but it's really not that bad. So let's go ahead and look at some explanations on what we do. I'm not too worried about this diagram part. If I were you, I'd just write the words down and the algebra terms down. So to complete the square for the expression x squared plus bx, you add b over 2 squared. So have that written down. To complete the square for the expression x squared plus bx, add b over 2 squared. So we take our b value, divide it by 2, and square it. And that helps us complete the square, so it becomes a perfect square trinomial. And then down here on the algebra part, if I have x squared plus bx, to complete the square, I add b over 2 squared to it. So x squared plus bx plus b over 2 squared. And then I can factor it, and it becomes x plus b over 2 times x plus b over 2, which is x plus b over 2 squared. Any questions? Can I go ahead and move on to the next example, or we're still right? All right, I'll give you a little more time. Once again, we shouldn't have any phones out on our desks at all. Let's look at the next example. Find the value of c that makes x squared plus 14x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So it's wanting me to complete the square for x squared plus 14x. Based on my previous slide, what do I need to add to be able to complete the square? What? B over 2 squared. So what's my b value in this case? 14. So the first thing I need to do is I need to cut 14 in half. What's 14 divided by 2? 7. I then take that value and I square it. So what's 7 squared? 49. So what's the value that I'm adding to my expression? 49. So the value of c that makes the expression a perfect square trinomial is 49. So let's go ahead and factor it. I'm looking for two numbers that multiply to give me 49, add to give me 14. What are they? 7 and 7. So this just becomes x plus 7. And that is my square of a binomial. So the value of c that makes it a perfect square trinomial is 49. And then the expression written as the square of a binomial is that right there. Does everyone see that? Not too bad, right? Take your b value, cut it in half, square it. That's you completing the square. Any questions? Can I move on? So now let's actually solve an equation by completing the square. So it says solve x squared minus 10x plus 7 equals 0 by completing the square. This is an example where our a value equals 1. The number in front of my x squared term is 1. So let's first off look at it and see if I'm able to just factor this right off the bat like usual. Are there any numbers that multiply to give me 7 and add to give me negative 10? No. So I'm not able to just factor normally, am I? So let's complete the square. In order to complete the square, I want my x squared term and my x term by themselves on one side of the equation. So what do I need to get rid of in this case to get them by themselves? 7. It's a plus 7. So what do I need to do to both sides to get rid of it?
Subtract 7.
Subtract 7 from both sides. So I get x squared minus 10x. I'm going to leave a little bit of room for me to complete the square. Equals negative 7. Everyone good with that first step? Just getting x squared and 10x by themselves. What's my b value? Negative 10. What's the first thing I need to do to negative 10 in order to complete the square? Negative 10 divided by 2 gives me negative 5. And then negative 5 squared gives me positive 25. So I'm adding 25 to complete the square. Does everyone see that? Now, can someone raise your hand and tell me what an equal sign means? What equals what?
Left side equals right.
The left side of the equation equals the right side of the equation, right? Means they're the exact same. So before I add 25, x squared minus 10x is the exact same as negative 7, correct? If I add 25 to this left-hand side, are they equal? No, because I just added 25 to the left side, correct? What do I need to do to keep them equal? Add 25 to the other side. So whenever you're solving an equation by completing the square, whatever you add to your left-hand side or right-hand side, you need to make sure you add that to the other side as well. Does that make sense? You got to keep the equation equal throughout the whole process. So now I can factor this. What are two numbers that multiply to give me 25, add to give me negative 10? Negative 5, negative 5. And then what's negative 7 plus 25? 18. Everyone with me so far? So this is x minus 5 squared, which equals 18. And now what do I need to do to solve for x?
Square root.
Take the square root of both sides. So I get x minus 5 equals plus or minus square root of 18. Any questions so far? Now the square root of 18 can be simplified. What's the biggest perfect square that goes into 18? 9. So I can break this down into the square root of 9 times 2. What's the square root of 9? 3. Can I take the square root of 2? Nope, so it stays under the radical. So I get x minus 5 equals plus or minus 3 square root of 2. And then how do I get x by itself? Add 5 to both sides. So x equals 5 plus or minus 3 square root of 2. And I can leave it like that unless it asks for a more specific answer. If it asks for a more specific answer, I would type 5 plus 3 square root of 2 into my calculator, give the decimal or fraction, whatever it gives me, and then I'd also type in 5 minus 3 square root of 2. Does everyone see that? But if not, I can just leave it like that. 5 plus or minus 3 square root of 2. Questions on example 3? Still not too bad? Example 4. Last example. Now let's solve an equation whenever a does not equal 1. Some number other than 1. Solve 3x squared plus 12x plus 15 equals 0 by completing the square. What do you think I could do to this equation to get rid of that 3 in front of x squared? Say what? Factor out 3 or divide both sides by 3. What's 3x squared divided by 3? X squared. 12x divided by 3? 4x. 15 divided by 3? 5. And lastly, 0 divided by 3? 0. Everyone good with that? That wasn't too bad, was it? Okay, are there two numbers that multiply to give me 5 and add to give me 4? There's not, so let's complete the square. What was the first step I need to do? Subtract 5 from both sides. Get that x squared and x by themselves on one side of the equation. So x squared plus 4x equals negative 5. What's my b value? 4. What's the first thing I do to it? Cut it in half, which is 2. And then what do I do with that? What's 2 squared? So what am I adding to both sides of my equation? I'm adding 4 to both sides. Whatever I do to the left, I have to do to the right. Questions on how I got what I got? Am I moving too fast? Okay. So what are two numbers that multiply to give me 4, add to give me 4? 2 and 2. Negative 5 plus 4? Negative 1. So that'd be x plus 2 squared equals negative 1. And then what do I do to both sides now? Take the square root of both sides. So I get x plus 2 equals what? What's the square root of negative 1? Huh? There we go. bi. Plus or minus I. Remember, complex numbers. 2.4 was just before 2.5 in the book. So now we're still dealing with complex numbers. So we can deal with an I now. We know how to take the square root of negative numbers. How do I solve for x? Subtract 2 from both sides. So I get x equals negative 2 plus or minus I. That'd be my answers. My two solutions. X equals negative 2 plus or minus I. Any questions with that one? Not too bad. That was our last example. Pretty easy. Here's our assignment. Page 140, 2 through 20 evens. 26 through 36 evens. Make sure we get it written down so I can project the book page up onto the board. This will be due Wednesday, December 9th. On Canvas. Gives you a couple of days to do it. Page 140, 2 through 20 evens, 26 through 36 evens, due Wednesday, December 9th on Canvas. Any other questions before I turn the recording off?